Hello and welcome to our discussion of support vector machines as part of Module 4. Jumping right in, um, so a support vector machine is a means of doing classification. So at the end of the module, hopefully you are able to apply it and also be able to explain how they work, how you use them in practice, and then be able to talk about things like kernels, regularization, gamma and margin tuning. So those are kind of key characteristics. So jumping straight in, what is a support vector machine? And the basic idea here is it's a type of supervised learning, like most of the ones that we've talked about in this course. So that means you have to have basically labeled data. And the idea is to classify things into essentially groups or classification. So it's all about classification. And it's about drawing lines between the classes, and not just drawing a line between them, but also having that line having a width. So you could think of it as a confidence or a probability of being correct whenever you have future values that come along and you classify them. So you have a sense of not just is it part of group A, but you're pretty confident that it's part of group A, or maybe not so much. So the way this works is kind of familiar to some other things that we've talked about in the past. It's all about increasing the dimensionality, right? So something that can't be classified in 2 dimensions, you essentially take to 3. That's the kind of idea. So as you move into higher levels of dimensions, you may even be introducing your hyperplane, which we talked about in the past, is nothing more than an abstraction of basically n+1 dimensions, right? So you're just going up another dimension beyond that of 3 dimensions. So you need something that's more interesting to intersect that thing that's in higher dimensions. So how does it work? And it's actually a really cool thing. But the way that it works is it's about, you do that transformation via a function. We call that function a kernel. And it's a means of doing that transformation. And like a lot of things, there's different types of them. You have a linear transformation. So you basically, it's kind of like the name implies, it's a straight line that you're potentially moving around a little bit, but it is straight. A polynomial, as the name implies, it's about something that's more than straight, so it can curve. And then you have exponential, and there's other types of kernels as well. Those are 3. But you'll see that there are more than those. Hey, John. I'll go ahead and back up a little bit. You're not very late. So what I thought I would do today is go ahead and go over support vector machines, which is Module 4. The idea being go ahead and go through most of these modules, and then we can circle back as needed. Module 4 centers on support vector machines. Support vector machines are pretty cool technology. It's about classification. And by the end of the module, the idea is that you're able to use them. So you can use a support vector machine on your favorite data set. And then also, more importantly, you can explain how it works or why it works, and be able to talk about it in terms of things like kernels, regularization, gamma, and margin tuning. So what is it? Always a great question. It's the first thing I usually ask anytime somebody tries to explain something to me or I run across something. And it is a supervised learning mechanism. So basically you have to have a labeled data set. And it's all about doing classification. So separating things with some sort of a line. But the important part here is that line has a width. So you have a confidence. So unlike some of these mechanisms that we might use, you have a confidence interval or a value. So you might think that you're 80% confident or something. You can think of it that way. But the width of the line denotes how comfortable you are, and how far the point is from the center of that line gives you an indication of how strong your prediction is. And like some of the things we've used in the past, it's all about increasing dimensionality. So taking something that you can't easily classify in 1 dimension, transforming via a function to a higher dimension where you can actually do the classification. Kind of sounds a little familiar, right? Because we talked about stuff like that in the past. And as always, whenever you get into higher than 3 dimensions, we start talking about things like hyperplanes, which just basically is an abstraction, a concept that it is something in a high order space that's being utilized to separate points. So it's similar to a plane in 3 dimensions, but it works in higher level dimensions. So probably sounds a little familiar, right? So how does it work? And I kind of spoiled it already because it's all about that transformation. So you run. Hey, John, did you have a question?
Oh no, I was nodding in agreement.
Yeah. So, and again, this stuff sounds awful familiar, right? Anyway, uh,
So,
so that basically the fancy word they use is a kernel, and a kernel is nothing more than a transformation function. And there's various types of them. If you're doing a linear thing, it's like the name implies, it's about a line. Polynomial, you're moving into something that is potentially curved, and then you can go into exponential, and then there's other ones as well. So those are just 3, but there's lots of different kernels. Regularization, and it's kind of a concept of how careful do you want to be, right? And you're kind of trading off the width of that hyperplane for perhaps accuracy initially, right? And like a lot of things, you might want to be cautious of overtraining here or overfitting. So you might do really great on your training data, but if you see something new, maybe not so good. Gamma, it's basically, like I kind of mentioned, it's how far you are from the middle of that line. High gamma, whenever you're doing the determination, only those points that are close to it are used for the classification. Low gamma, further away are also considered. The margin, the separation of lines to the closest point. So ideally you want a good margin where basically your line's kind of right in the middle. Bad margin, you're kind of too close to one side or the other. So these are just kind of terminology that is often used. And so now we can jump into the fun stuff, and hopefully it'll actually work today. While I'm doing that, any questions so far on anything else?
no, not so far. I was looking at the assignment for Module 3, and it looks like we'll be doing a convolutional neural network for differentiating a dog from a cat.
Yep, yep. And it's almost like a walkthrough, right? And we can take a look at
Right.
that in a little bit because there is one little gotcha that I remember running into with it. But it's
Okay.
all about having the right version of. Well, we can do it right now. It's just the two of us. So while I'm navigating.
That's a pretty darn cool thing, you know. I'm excited about digging into that one.
It was module 3, right? Two examples. Is this one? Yeah, the trick here, you want to make sure you get Pillow 8.2.0 installed. So you want that particular version. I ran across that. If you don't, you get some weird errors, right? And it's all about, it's some sort of this import pill, and if the version's not quite right, bad things happen, right? Um,
And what is that library again? Pill?
yeah, pill. I can paste that in the chat as soon as I find the window.
Okay.
And don't do it unless it's not working, right? But whenever I did it, it gave me grief. Things sometimes change though, so that's basically just saying make sure that you've got Pillow 8.2.0 installed. Other than that, it was pretty straightforward, and there are the link in the assignment actually takes you straight to basically a walkthrough in a book, right? So. But it is an interesting exercise. It takes a little while to train, or at least it has on my machine lately, but I'm running
Yeah.
a earlier kind of a pre-release of Windows 11, so sometimes odd things happen. But anyway,
Yeah.
uh,
Sure.
the challenges of being an early adopter, right? So anyway,
Yep.
going back to, and like I said, if you have any questions, let me know. That was one thing I ran into, but in the book, the that you link to off of that that resource in the deliverable, it is pretty much straightforward. So
Okay.
yeah,
Cool.
and it's a good exercise because you don't want to get over your head too easy or too early on it. So a nice win. So what this is doing is an example of doing some classification. I took it out of this text, which probably won't work in that window. Actually did. Interesting. So this is actually a pretty good text. A quick learning, or machine learning quick reference was a pretty good one, and it does a pretty nice job kind of explaining stuff. So I stole this example from, stole it, it's not giving them credit, but it's out of the resources that go with that book, and in particular chapter 2. And so the basic idea here is to kind of just walk through a fairly simple example. You start off in doing your typical sort of imports, and in here where the main one we're interested in really is this, let me make that bigger. There you go. Not big enough that my toolbar loses itself. All right, so there we are. So hopefully you can see that pretty well. We're importing SVC out of SVM from sklearn. Then we can load the data set that is breast cancer, another one that you've probably seen before because it's been around quite a bit. This gives you kind of, I think it's been in several courses. This is the one that's got the images, and there's the whole symmetry, concave, classification, I think is where this one was.
Yep, it was the classification class for sure.
And so
it was with Dr. Dax Bradley for that one.
So the typical next thing of doing a test train split, so that because you've never seen that one before either. All right, so the next part here is this the C, and if just jumping back to my PowerPoint, that's where I was talking about C in here, right? The regularization is how much do you want to avoid that misclassification. So we're starting off with a C of 1, which it's one of these hyperparameters that you tune to do to see how well you do. You're using a linear kernel, and that's one of the things. I usually have a link to the thing, so maybe I can just Google it. Of all the different kernels is what I was going to show you, because there are quite a few. Maybe this will do it. Here we are, kernel functions. Okay, so there's 4 in this one: the linear, polynomial, sigmoid, and RBF, which I'm not 100%. That's a radial basis function. So yeah, I should have known that one. So again, it's these are basically kind of the things that you try to see how well you do, and that's kind of what this example is doing. So we go through, we've done our split, so then we can do our training, and then and actually that's pretty respectable, right? On test, getting almost 96%. I think that's better than we did in classification, if I remember correctly. Trying it with the radial basis function, or whatever it was, bias function, not as good on so that almost kind of hints to me like at an overfitting, perhaps, because you got 100% on the train. And then the part here that's interesting is, go ahead and run through the end of it's where it gets interesting, because here he actually does a grid search to determine kind of what are the best hyperparameters. So it's kind of essentially running through all kinds of combinations, kind of reminiscent of maybe AutoML, but at a simplistic level, right? And that's a common sort of trend you'll see in this field, is things that can be done through just repetitive running are. So it's going to take a little bit. But basically it's trying lots of different parameters to determine what is the best fit. Although I think it'd be hard to beat that 96%. It takes a little bit. Have you worked with support vector machines before?
I have,
Okay.
and I've always thought they were pretty cool. They remind me a lot of, in 2 dimensions anyway, linear regression, right? Except, the vectors are supported by the lines that are the widest possible, as they're struck through that 2-dimensional space.
Yeah.
And the vectors that actually touch the lines are the support vectors. I've had pretty good luck classifying it. When I was an electricity trader, I would use this to investigate potential congestion price splits on the electric grid. And it did really, really well with that.
So here we can see that it actually, likely them choosing a C of 1 was not a coincidence, right? Because that happened to also be the the best value, right? So I'm kind of guessing this demo probably worked backwards, which would be my guess. So they happened to guess the best one out of the box. Funny how that worked out, right? Anyway, but you see that a fair amount in some of these demos. So moving on to the next one. I thought I fixed that. Let me get out of this for a second, because it's the link in the text are different is the problem. Yeah, I thought I fixed it. I thought, but maybe it didn't get uploaded, right? Because this is actually a pretty cool one. Is it still doing it? Not sure what that's about. Let's just do it the old-fashioned way. And this one I stole from a website, and it was actually a pretty interesting idea of what was it? Basically a rancher or a farmer goes to the rodeo. So it's about trying to detect cows and wolves, right? So being able to separate them. So humorous anyway, right? This similar sort of thing, importing SVM from sklearn. And this is kind of cool because it actually does a plot for you, which is good. Opens up a text file. I learned after all of my being clever in Jupyter, if your notebook's in the same folder as your data, you don't have to do anything. It just works.
Oh, really?
Yeah.
Oh, I didn't know that.
Because I did all my, making it work underneath of, the Windows subsystem for Linux or on different computers and all this other stuff. And but if you're in the same folder, then it just works. And
oh man, I'm glad you told me that. That is such a pain in my neck.
It's like thinking I'm being clever, and then I just figured it out. It's like, huh. Anyway, so similar thing here. We've got some data. We're loading it up. A little nicer here because we're actually kind of doing it in a little more structured way. I need to turn off my phone. Anyway, so the cool thing here is it shows you, after it does its work here, how well it does with each one of those regressions, right? And the SVM beats logistic and decision trees. Pretty much, and in a nice kind of clean way, right? It doesn't seem artificial to where the decision tree seems a little artificial. But this article goes on to, well, why not just do SVM everywhere, right? And it's that back to the whole explainability thing, right? Why did it work? And you can easily do that with a decision tree. You can explain it to someone, right? SVM, not necessarily is easy to explain, especially.
Yeah, I have a really hard time with the hyperparameters going up into, 7-dimensional space. I can't get my head around it, so I just take for granted that it's doing what it's supposed to.
Well, and especially though, if you had to explain that to a stakeholder, right? So
Yeah. Yeah.
if you're saying, well, the reason why this is right is because of that, then unless they've got a background in mathematics, they're probably going to be a bit skeptical, right? Um,
Yep.
but I thought this was a real nice sort of plot that they do. And it shows nicely how it's working. And if we go back up, seeing which one they were using, did I look right over it? I was trying to see which kernel it was, but I'm not seeing it. Must be just using the default. Anyway.
When people talk about deep neural networks, are they talking about the number of hidden layers? Is that what they mean, or does deep
Yeah.
mean something
No,
deeper than that?
it's a more than 3 layers in a network is considered deep. So if there's more than one hidden layer, then it's a deep network. And anymore, most neural networks are deep, right? So that's not a great name anymore. But that's all it means, is that you've moved past one hidden layer.
Cool.
Yeah. So here we're our good friend Iris, right? Data set. No conversations complete without Iris, right? Helper functions here to kind of set things up. A lot of these I'm pulling in from various Python files so that I can show them in a cleaner way inside of Jupyter. Loading Iris, and then creating our models. Again, a nice sort of way here of doing multiple, essentially what is that, a list of models, and then going through them and fitting each one. So it's probably going to take a little bit. Won't take too long. And then going through, and basically this is going through a bit of more of a discussion on the those 4 kernel methods that are in the scikit-learn anyway. I've seen more than this. I'm trying to remember what the other one was, but I've seen another one or 2. So anyway, this is all about kind of setting it up to do the plot of the nice little graph. And here it's showing, going off of, what is that, Sapel width and length, of how well it can do with the various kernels. To me, none of those are fantastic, right? So I guess it depends on kind of your criteria. And this is kind of a problem, I think, with Iris in general, is that, like in this case, the blue dots are pretty easy to classify. It's the red and the white that are always hard to pull apart. And I've seen that over and over again with Iris. It's just like they're almost too close to tell using just width and height, or width and length of the Sapel. And one more. This is going through, and again, this is straight out of the documentation, right, of figuring out, coming up with the maximum margin, separating them out. And so it's always a good idea to take a look at the actual documentation on it, and this is kind of showing you how it kind of figures it out. Not terribly relevant, because it's a pretty simple thing, but it's still a nice graphic, and it shows you visually that concept of the margin and where the points are, and how it's picking only the ones that are the closest, right? So that would be that. Anyway, so going back in here, try to see if this thing will actually work right this time. I fixed it earlier, and then that time it's right. It was weird, because it kept wanting to do the one beneath it, which confused me for a little while, because I clicked on it in okay, deliverable 4. You guessed it. You're supposed to do some classification with support vector machines. Basically, pick your favorite data set. So it doesn't. We don't supply one. We don't pick one. So pick whatever one you like. Then apply SVM to it, and do your own basically classification. Then basically create a report essentially with your results explaining what SVM is, explain what a kernel is, regularization, gamma and margin tuning, gamma and margin, and then the tuning of those parameters, so kind of the hyperparameters. The criteria, pretty straightforward. It's those 3 points. Did you do them? And so should be pretty straightforward, especially given you've done a fair amount of work with it.
Mm-hmm.
So the see if I can find that cats and dogs thing again, because that's actually kind of cool.
Yeah, it's a super cool ask. I'm a little, intimidated by it, but I know it'll be something I can do if I just do the steps. But
Yeah.
kind of scary.
Of the support vector or the cats and dogs?
Cats and dogs.
Oh yeah. It's
It's fascinating to me if that's possible because there's so many similarities.
Well, I think it depends on the cat and on the dog, right?
Yeah. I was thinking about a pug, a pug and a kitten that's really fuzzy. They look a lot alike.
And so basically, this link is what's, I believe, in your classroom, and I have too many identities here, but there we go. I'm a huge fan of the peoples inside of Chrome as a way of separating out different organizations I might work with. So, like, even if I'm doing consulting and I go to work at a new contract, on a new gig, I'll create a new identity so I don't have to let it confuse my other stuff. So anyway, basically this link takes you into cats versus dog image classification, right? And it's literally, it goes step by step of what to do, including you start off by cloning their code and then creating an environment with this conda environment create using the environment YAML file, then activate it, install a thing, which I was kind of curious why that wasn't done in the requirements, but the environment. But anyway, and then go inside of the code that we just pulled down, which is basically what I just opened up here. Although I took these files and merged them into a notebook because I don't like just Python. And there's lots of narrative, but it basically kind of walks you through it. So,
and that is a link that's in the module 3.
Yeah, it's in the deliverable. Yeah.
Oh, in the deliverable. Okay.
Deliverable folder. There's a let me see. I could probably switch into too many windows open. Man, do I need to close some windows?
Can never have enough windows.
All right, I'm going to take this off screen and do a little bit. Don't want
to. Okay.
Give me one.
So you basically walk through this.
Yeah.
All right, awesome. Yeah. That's a nice introduction to this kind of thing. Well,
and it goes through, and the biggest thing that I did was kind of clean up their code and pull it over into a notebook. It's just because I'm me. You wouldn't have to. So where am I? There we are. Okay. Here. Where did it go?
This actually seems like a pretty good book. What book is this? No. Context with Python. Huh.
Yeah. Yeah. Yeah, I actually took a look at it. It wasn't bad. It kind of gets you through it pretty well. And it also you kind of get it. This walkthrough is not bad at all. It kind of guides you along nicely.
That's great. That's something that I'm very curious about. Very cool.
Yeah, and it's let me run through it real quick. And it's a fairly common one. You'll find it if you Google cats versus dog or whatever neural network. You'll find a lot of them. But they basically walk you through all the constants of the hyperparameters, um, and then essentially constructing the model by doing that sort of the convolutional 2D and then a pooling and repeating over and over again with a flattened and then dense and then dropout. So this is kind of you see that recipe, for lack of a better word, quite a bit. Making sure that doesn't tell me anything I need to know. And then it goes through and does some rescaling of basically kind of shrinking them down. And then it does take a while. So it looks like it's going to be 5 minutes or something to run. And this, I'm not running on a wimpy machine. So although it's not using my GPU, I need to fix that because it's not using my GPU. So that's why it's so slow. It's just using the processor.
Pretty crazy the amount of work it's doing, though. I mean, these processors these days are so powerful.
Yeah, he's bringing up Task Manager. See if we can. Well, it doesn't help. I got a bunch of windows open, but it's probably pegging out my. Well, it's not even pegging it out necessarily. But it's, you can see the GPU is not really doing much at all. You might be using it just a little bit. Yeah. Because that's about when that started.
How do you like Windows 11 as an early adopter?
It's not bad. I don't quite really get the branding though, because it's just Windows 10 with curved corners, basically, is what it seems to me. So, okay. And
I'm really happy with 10. You know, what could they possibly do to make it better?
There's some stuff that they're doing as part of it, like the Windows Subsystem for Linux is where I'm actually running this Jupyter instance from, and it's supposed to be supporting because this is actually inside of a Linux machine running inside of a VM. Sort of. It's more first class than that these days. But it's supposed to be doing GPU pass-through, and it looks like it might actually be now, because that's using my GPU, just not as much as it should, because that's only like 10%. But that could be limitations in Python too.
Yeah.
But that's it's actually some pretty cool technology, and the image classification, they're CNNs are really good at it, and a lot of the stuff that you kind of like image detection, a lot of that stuff it's using CNN. So if you are looking for something in an image, whatever it might be. I don't know, maybe a license plate or a car, or that sort of thing. It's probably what's being used. There are some other things that may be being used if it's like a video stream, but if it's just like an image, snapshot image, they're pretty good. And what's amazing to me, I don't know if you've played with like Google Drive or Google Photos, but Google Photos now is pretty good at if you search for cows, if you have pictures of cows, it's actually pretty good at giving you back pictures of cows. So
that's cool.
Also people, which is kind of creepy, right? But
yeah.
if it knows who someone is and you search for that name, it'll find them a lot of the time. So wow. kind of good and kind of creepy. But it's like everything else. You're trading off a certain amount of privacy and whatnot for that benefit. You can see there that the validation accuracy anyway is running around 60%, which is right more than it's wrong. So that's not bad.
Yeah, it's pretty good.
I mean, there's times that you'll take that. Creeping up, this ever so slowly. Another minute or so and it should be done.
Wow.
It is doing a certain amount with my... It's keeping it a little busy, but it's an odd pattern. Because it's yeah, it's very odd. You would think that it would, if nothing else is going on, that it would pretty much take all the cycles, or at least,
Yeah.
or you'd see at least, 2 or 3 of the cores pegged. But that's kind of an odd behavior.
Yeah.
Although it is like in my disk drive right now, so
It'll have its tongue hanging out by the end of that.
yeah, it did something there. Okay, yeah, so we're not going to wait around for that. That was just one epoch. So,
Wow.
yeah. But that's interesting. At the end of that first epoch, it's 63%, and now it's already up to 70%. So it's probably going to do pretty well. I think you'll be probably surprised. But that's,
Cool.
yeah, pretty good stuff. So yeah, and if you have any challenges getting it to work, let me know. But I do remember having to fight with this whole pillow thing. And the error message you get was not all that helpful, right? So
Yeah.
it's one of those, you have to Google the error message and then scroll through all kinds of not relevant stuff to find the stuff that actually is relevant, right? So
Yeah, I actually already went and installed it. So
yeah,
just
yeah,
like, I appreciate the heads up on that one.
yeah, because it'll definitely save you some time. Yeah, and if you have any trouble with it, let me know. Don't be overly concerned. I think you'll knock it out because it's pretty much going through it. The biggest thing is making sure you understand what it's doing, right, and how it works.
Yeah, that's what I'm going to go for. I'm going to walk through that and just enjoy the ride.
Yep. All right, sounds good. So if you don't have any other questions, we can go ahead and wrap this up.
All right, sounds good.
All
Thank you as always for all the good advice and instruction, and then I'm sure I'll come back with thoughts on this one. I'm pretty excited about this one.
Yep, you're quite welcome. And if you get stuck, let me know. I doubt that you will, but if you do, then I do what I can.
You bet.
All right.
I'm not a proud man.
All right. Appreciate you joining
Okay.
as always.
Yeah, you bet.
All right. Talk to you later.
All right, see you again soon. Take
Yep.
care.